Next, we move on to interaction terms. So I began by basically importing poly features from like sklearn and the pre-processing. And then I did interaction features equal to h scaled all the way to old peak scale. Basically selecting the features to create like interaction terms. Then I move on to polynomial features with these parameters all the way to interaction terms. With polyfit transform df process brackets interaction feature. Basically this creates like a polynomial feature which includes like the interaction terms. Then I move on to interaction term names equal to Paul. I get features names out with these parameter all the way to interaction only name for name in interaction term if back in name. Basically this block of code gets the name of like the interaction terms. Next we move on to interaction df is equal to pd.dataframe interaction terms columns and equal to interaction term names. Basically this creates like a data frame with the interaction terms. Then we move on to interaction df is equal to interaction df. Interaction only name. What this block of code does is it keeps like only the interaction columns and basically not the original features. Then we move on to df.process equal to pd.concat brackets df process equal to resting index drop equal true, comma interaction df equals resting index drop equal 2, comma access equal to 1. Basically this adds like the interaction term to like the process data frame. Then we move on to like print create lens interaction only by names all the way to display interaction only by names. Basically this displays like the interaction terms created and then display df process interaction only names head. Basically this displays like the first few interaction terms. So here we have like the created 10 interaction terms, h scaled at times resting bp scaled all the way to max HR scale times like old peak scaled. And here we have like the first few rows for this. So for the age scaled and resting scaled for all the way to like max age scaled to old scaled. So yeah. Next we move on to interaction correlations equal to df processed interaction only names plus heart disease correlation heart disease drop heart disease. Basically what this line of code does is it calculates like the correlation between like each of like the interaction terms and like the target variable like heart disease. Then we move on to top interactions equal to interaction correlation dot absolute sort values ascending from false dot head. Basically this line identifies like the top 10 interaction terms that are like most strongly correlated with heart disease. Then afterwards we display it by using display top interactions. So these are the top 10 interaction terms by correlation with heart disease. The first one is age scale times cholesterol scaled all the way down to like resting BP scaled times cholesterol scaled. Then here in this graph, we basically visualize the top 5 interaction terms. So the first one is age scale times cholesterol scaled all the way down to like age scale times old peak scaled. So yeah. Next we move on to data processing and splitting. So data frame is equal to pd.get dummies all the way till y is equal to df process brackets heart disease. Basically what this block of code does is it basically handles any of like the remaining categorical columns and uses the pd.getDummies function to one hot encode the remaining categorical variables and separates the target variable of like heart disease into like y. Next we move on to feature groups is equal to these parameters. So basically what this block of code does, it organizes all the features into like the logical groups using like dictionary comprehension. So basically now the groups would be like original numerical, Wanaha encoded, scaled, and then binned. Next we move on to original features equal to feature groups brackets original numeric plus feature groups Wanaha encoded. Basically this creates like a base feature list over here. Then we move on to feature sets equal to ordinal features all the way to like all the features. Basically this creates like a feature sets for like the model comparison later on. Then we move on to for name x in feature sets the items print f name equal to x shape. Basically this displays like the features set dimensions. So for example, original features have like a shape of like 918 rows by 15 columns, all the way to like such as like original plus interaction, which has like a shape of like 1918 rows and 25 columns, and all features have 118 rows and 51 columns. So yeah. Next we move on to basically splitting the data into training and testing state. So I'd imported train test split from sk.model.selection. The test size equal to 20. Basically, this sets aside 20% of the data for testing, with the 80% basically being used for training. Random state is equal to 42 ensures like reproducibility by using like the same random seed for all the splits. And then we have a train test data is equal to empty bracket sets. Basically, this creates like empty dictionary to store like the splits for each of like the feature set, and this enables like organized storage and access to like different train test splits. Next, we move on to for name x in the features sets items all the way to like print f name train x train shape test x test shape. Basically what this block of code does, that this loop basically calls the train test split to like divide the data into like training and testing portions, and then it sorts the resulting like splits, like such as like the x train and x test, y train and y test, into the dictionary with like the future set name as like the key, and then later on it basically prints the information about the dimension for each of the split. So here we have like the information for the original features train for like 734 rows and 15, with the testing one as having 184 rows with 15 columns, all the way down to like original with the interaction, which has a training set of like 734 rows with 25 columns, testing one having 184 with 25 columns, and all the features having a training shape of like 734 rows with 51 columns, and testing one having 184 rows with 51 columns.